Couple more things I want to point out about the magnetic field before we end today. Do you guys happen to know what liquid conductor the Earth has? Now, a while ago, some of you guys mentioned that the Earth has magma inside. But magma is not a good conductor, okay? So there's another kind of liquid we have in our planet that's deeper down in the core of our planet. And does anybody know what the core of our planet's made out of? What kind of stuff? Well, deeper down. See if you guys got a couple guesses for me. Metal. Liquid metal. In our core, part of it is melted liquid metal. Specifically, most of it's iron, right? Most of it's iron, but there is liquid metal in our planet that is making our magnetic field. And any terrestrial planet that has a magnetic field, it's going to be liquid metal. Based on our other clues, based on the fact that our density is high, and based on the strength of our magnetic field, we know that it's got to be a liquid metal making that. And check this out. In order to have liquid metal, what kind of temperature must the core of our planet have? In order to have that liquid metal, what's the core of our planet got to be like? Hot, right? It's got to be hot, okay? So, in another way, the magnetic field backs up the fact that our planet is hot inside. Just like the number of craters told us that we were hot inside, the magnetic field also tells us that we were hot inside, right? So, let's go through these planets real quick one more time and see if we can figure out which planets it would make sense to have liquid metal and therefore a magnetic field inside of. So, does it make sense that Earth has liquid metal inside? Yes. We know it's hot inside because it doesn't have that many craters. So we know it should have a magnetic field. Okay, how about Venus? Would we expect Venus to have a magnetic field? Yes or no? Based on the fact that it has a lot of volcanoes, that tells us it's hot inside. And since all of the terrestrial planets are made of the same stuff, Venus is about the same temperature inside as us. So that means it should have just as much liquid metal as us, okay? Now, how about the Moon and Mercury? Would we expect them to be hot enough inside to have a magnetic field, to have liquid metal? No. No. And Mars is a little bit of a special case. Mars is in between, so you might not be able to guess. But remember, what did I say happened to all of the volcanoes on Mars? It has volcanoes, but because it's small, it cooled off a long time ago. What's happened to all those volcanoes? I think I said this. Mars, all of Mars's volcanoes have died, okay? Mars's volcanoes have died because it has lost so much heat and cooled down, its volcanoes have died. So should Mars have a magnetic field? Yes or no? No, right? Mars should not, okay? And that is correct. Mars does not have a magnetic field. It may have had one a long time ago when it was hotter inside, but since that planet has cooled off, its insides have totally solidified, or at least mostly solidified, enough that it can't have a magnetic field anymore. So, check this out. We said Earth should have a magnetic field, and it definitely does. We said Mars should not have a magnetic field, and it doesn't, so we're good. Same thing with the Moon. We said it should not have a magnetic field, and it doesn't. So everything's good so far. Venus, we said it should have a magnetic field. But it doesn't. It doesn't. Uh-oh. Okay. So, kind of seems like we've got a little bit of a hitch in everything that I've said. Venus is hot inside. Venus has got liquid metal, but it doesn't have a magnetic field. So why? Why? What's wrong with Venus? What's wrong with Venus? Venus really should have a magnetic field, but it doesn't. Let me go back to that definition of a dynamo real quick. Let me go back to that list. So I just got done saying that Venus does have liquid metal inside. It does have a conducting fluid. Yes, if somebody pointed this out, something must be up with the rotation, right? Something must be up with the rotation. And the rotation of that material partially comes from the rotation of the planet. Don't overthink this. How many days does it take Earth to rotate? How many days does it take Earth to rotate? One, right? 1 day. It takes 1 Earth day for Earth to rotate, which is pretty fast, right? And that rotation is one of the things that helps this dynamo get that rotation going. It's not the only thing. But Venus, as you guys were saying, has a problem with rotation. Specifically, Venus takes over 280 days to rotate. 1 Venus day equals 280 Earth days. So Venus could have a magnetic field. It's got the juice inside to do it, but it's just not, it doesn't have its dynamo going, right? It rotates way too slow to get enough spin going on, okay? So check this out. If you wanted Venus to have a magnetic field, what would you have to do to it? If you wanted to give Venus a magnetic field, what would we have to go do? Yeah, you just go spin it, right? You just go get up there and just give it a nice smack. Just go up real close and just, if you could just, it's like slap Venus upside the head, you'll get it spinning a lot faster. A magnetic field would probably turn on in that case. So yeah, just, and then you're good. Here's one last thing for these planets. We said Mercury should not have a magnetic field. But when we measured closely, it turns out Mercury does have a weak magnetic field. Okay? Mercury does have a weak magnetic field. So that means that something must be artificially keeping the very, very, very core of Mercury a little bit hot. Okay? I say artificially, it's natural, but normally, we would expect Mercury to have completely cooled off because of the number of craters. But, yeah, somebody pointed this out, the sun is able to keep the core of Mercury a little bit hot. But it's not for the reason that you're thinking. Because it's not the sun's heat that is doing this, okay? The sun's heat is not keeping Mercury hot. It's something else from the sun that is keeping the core of Mercury hot. Do you guys know what it is? I'll go ahead and tell you, because I don't think you're going to guess it. It's gravity. It's gravity. The gravity of the sun is what's doing it to Mercury, okay? It's because of because of what's happening to Mercury while it's orbiting. Now, check it out. Imagine that I'm the sun, okay? Imagine I'm the sun. Which part of Mercury feels the most gravity from the sun? If this is where the sun is, which part of Mercury feels the most gravity from the sun? The left side, the top? So let's just say up, down, right, or left. Which side feels the most gravity from the sun if I'm the sun? Left, right? And which side feels the least gravity from the sun? So the left feels the most gravity because it's the closest. Yeah, and the right side, back here, this side would feel the least. And that's true for every planet, right? But because Mercury is so close to the sun, this side, the front of Mercury, feels way more gravity than the back. So this side, the left side in this picture, is being pulled harder than the back is. What is that going to cause to happen to Mercury? If you pulled one side more than the back, what's going to happen to the shape of Mercury? Put it in simple terms. Yeah, Mercury gets stretched out. Technically, the gravity of the sun is stretching all of the planets because of this. That's just like the tides, right? It's just like the tides. The side that's towards the thing gets pulled more than the side that's away from it. So we sometimes call this a tidal effect, okay? But yeah, the sun's tidal pull, because of its gravity, causes all the planets to stretch out, but Mercury gets stretched out the most because it's the closest. Does that make sense? And what that does is this. When Mercury spins, it's constantly being stretched into a slightly egg shape, okay? Mercury gets stretched into a slightly egg shape, and then it rotates, and then gets re-stretched. But is Mercury made of stretchy stuff? Is Mercury made out of stretchy stuff? It's made out of rock. Is rock stretchy? Rock can stretch a little bit, but not much. Rock is not stretchy. Mercury's made out of rock and metal. It's not very stretchy stuff, right? Yeah, so some rock with moisture, you can think of clay as stretchy, but that's a special case. In general, rock is not stretchy, okay? But what does that do? That means that because the sun is constantly stretching this stuff that's not stretchy, it's causing grinding of that rock. Inside of Mercury, that rock is grinding. And when you're grinding rock, what do you get? If you're grinding rocks together, what happens? And please answer quickly because it's starting to feel it right now. Yeah, you get friction. And as we talked about last time, friction causes heat, right? So basically, the gravity of the sun causes the inside of Mercury to grind, and that grinding causes friction, and just enough to liquefy a little bit of the core of Mercury, enough to give it a magnetic field, but not enough heat to cause things like volcanoes, so it doesn't have that crater erasure. Okay. So let me review that real quick just to put it all together. We said Earth should have a magnetic field, and it does. We said the Moon and Mars don't have magnetic fields, and we were correct. Venus should, but because it rotates too slow, it can't have one. And Mercury shouldn't, but the tidal effect of the sun gives it a weak little magnetic field. And by the way, all of the Jovian planets have magnetic fields, but we'll talk about what causes that magnetic field when we talk about the individual